We all now know the need to eliminate greenhouse gas emissions. Climate change is real, and it's set to have a massive impact on future generations. Every time we burn fuel, we take carbon dioxide from those prehistoric forests that has been stored underground and we release it into the atmosphere. We have done this repeatedly over time, causing immeasurable damage and a legacy that our kids and grandkids will have to deal with. But it doesn't have to be this way. What if we could put it back? What if we could capture that carbon and put it back under the Earth's crust? Well, this is what the team at Sequester have dedicated themselves to, and through engineering brilliance, they have the solution. They have worked out how to capture, transport, and return the carbon dioxide that our factories spew into the atmosphere into storage in the Earth's crust. The driving force behind Sequester is Chris Merrick. So Chris, a really big thank you for taking on such a meaningful problem.
Thanks very much. It's a project that we're very passionate about, and it's not really about the recognition, it's about making a difference.
Putting CO2 back into the Earth's crust is called carbon sequestration, but it has been very expensive. Chris and his team have made the process cost-effective and therefore removed the barriers for government and industry to adopt this methodology.
What we want to do is make these systems widely available so that industrial scale injection of CO2 becomes possible. And the system's good for 1 million tonnes per annum. And to put that into context, 1 million tonnes per annum is the same emissions as 285,000 cars. So one of our systems operating with one ship can be considered the way of taking 285,000 cars off the road or planting 40,000 hectares of trees per annum every year. So we would have to be planting something in the order of 178 million trees per annum to have the same impact as our system.
So how does the system actually work?
Well, we've got an offshore vessel. It's configured with storage inside the hull. We take the vessel, we take it to a port location near industrial emitters. We hook up to their captured carbon source. We load it onto the vessel, sail offshore, hook up to our well, which is called pivot tree, simultaneously the well injection control and the mooring for the vessel. We inject it downhole, drop the mooring, head back to shore and do the same process again.
So you're putting the CO2 essentially back where it came from, back into the bottom of a well?
That's right. So we're using subsea reservoirs to sink very large volumes. We're targeting reservoirs using the same techniques as the oil and gas industry do. They're used in exploration. We're targeting reservoirs with very strong seals, with very large support in terms of pressure, so we can hold a lot of CO2, and they're very wide area.
A way to strive towards net zero and return the carbon dioxide to where it has been stored for millennia.